We're going through exercise 6C, and in this video we're looking at question 7a, which is asking us to use the rational root theorem to help factorize each of the following cubic polynomials. So here's the cubic polynomial we've been given. We need to factorize it, and we've been told that we're using our rational root theorem. Like our previous question, we're going to be following 3 steps to answer this, but let's just really zoom in and consider how this is different to what we were doing previously. The fact that they've told us that we're using the rational root theorem is extremely important because it's telling me that my root is not going to be an integer. So therefore my factor is not going to be in this form, x minus alpha. It's not going to be in that form, because if it were in this form, that means my root would be x equals alpha, and alpha would be an integer, and we know it's not going to be an integer because it's telling us to use the rational root theorem. Out in the wild, they're not going to tell you to use the rational root theorem. Rather, what you're going to do is simply put in a whole bunch of factors of 15 into this, trying to find that 0, but you're not going to find it. So then you're going to go to the rational root theorem. But as you can imagine, that would take quite some time, because think of all the factors of 15. You'd have to go through 1, 3, 5, and 15. So there's 4, and then you'd have to do the negatives of all those. So that's 8. I mean, it's going to take a long time. So the fact that they've told us that we're using the rational root theorem is rather nice. So it's not going to be in this form. Rather, the form that it's going to be is beta x minus alpha, which means that my root is going to be alpha over beta. So as you can see, I'm simply setting this equal to 0, then rearranging to find for x to get this. And the root is simply what you put in to get 0 out. And this is rational, meaning that it's just one integer divided by another. So this is going to be our root. And we know that because it's told us that we're using the rational root theorem. So this one up here, we're not even going to look at that. We're just considering this. And that's because we're told that we're using the rational root theorem. All right, so let's now continue. The next thing that we're going to do is figure out what this alpha over beta is going to be. So we have alpha over beta. What will this be? Well, what's it going to be? Well, we know that alpha is going to have to be a factor of 15, and we know that beta is going to have to be a factor of 2. So I just like to put those there to remind me of that fact. We're going to have to consider both positive and negatives of them. And now we're going to do that. I'm going to list out all my factors of 15. So 1, 3, 5, and 15. And then I'm going to list out all my factors of beta. So that's going to be 1 and 2, 1 and 2. So let's just recap what I did there. First, we're using the rational root theorem, which means that my factor is going to be in this form, meaning that my root is going to be in this form. To figure out what alpha and beta is going to be, I know that alpha is going to have to be a factor of 15, so I wrote all of those down. I know that beta is going to have to be a factor of 2, so I wrote all of those down. I'm going to write down everything I'm going to trial and error. So what am I going to trial and error here? So equals plus or minus. Now, I'm not going to consider anything that's an integer. So normally what you'd do here is you go, all right, 1 over 1, you'd have 1 over 1, you'd have 3 over 1, 3 over 1, you'd have 5 over 1, you'd have 15 over 1, then you'd have 3 over 2. So as you can see, I'm just making a whole bunch. Then you'd have 5 over 2, you'd have 15 over 2. So you're just writing down all the possibilities if these have to be your numerators and these have to be your denominators. But let me ask you something. What's 1 over 1? It's 1. What's 3 over 1? It's 3. What's 5 over 1? It's 5. What's 15 over 1? It's 15. So why can we ignore these? Well, these are integers. And we've already been told that we're not even considering those because we're using the rational root theorem. So we can immediately just go, bye-bye. We don't even have to look at you. We're just going to be considering these. So let me just rub these out for a second and just rewrite them here. We're going to be dealing with plus or minus 3 over 2. So I'm just rewriting those. Plus or minus 5 over 2. Plus or minus 15 over 2. That's what we're dealing with. So let's begin. Let's begin by putting in positive 3 over 2, and hopefully, please, 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 let that give us a 0. If it doesn't, we'll then go on to negative 3 over 2, then positive 5 over 2, then negative 5 over 2, and then onto this one until we find that 0. So this is where trial and error comes into play, and it's really just atrocious. So let me zoom out here for a second. What I'm going to do is I have p of 3 over 2, and what I'm going to do here is put this 3 over 2 into this. So it's going to be 2. So into this x spot, I'm putting 3 over 2 cubed minus 7, 3 over 2 squared plus 16, 3 over 2, and then last but certainly not least, minus 15. Let me now zoom in, calm down. Let's do some maths. This is the worst part of the job. Okay. So this is going to be 2, and then I'm going to do that. 3 cubed is 27, 2 cubed is 8, minus 7, 3 squared is 9, 2 squared is 4, plus 16 times 3 is 48, over 2 minus 15. I come down. I'm going to go 2 times 27 is 54 over 8 minus 7 times 9 is 63 over 4 plus 48 over 2 minus 15. I need all of these to be common denominators in order to plus them or minus them all together. So at the moment, because they don't have a shared common denominator, I'm going to have to fix that. I'm just going to make everything have a common denominator of 4. So that means instead of 54 over 8, I'm going to divide my top and bottom by 2. So that means I'm going to get 54 divided by 2 is 27 over 4. This one already has a 4, so I'm going to leave it. This one, I need to times it by 2 to get to 4. So that means I'm going to get plus 48 times 2 is going to be 96. 2 times 2 is 4. And then over here, this is 15 over 1. So that means I'm going to have to times this by 4 and this by 4, which is going to mean I'm going to get 15 times 4 is going to be 60 over 4. Oh, there might be a better way to do this, but we're already committed now. Oh no, this is, I don't know. Let's keep on going. Now I'm going to gather together my positive ones. So my positive ones are going to be, wait a second. Wait 1 second. Look at that. What happened there? That should be a negative. Oh, I'm not starting this video again. Could you imagine if I had to start this video again? Horrific. Just please don't make silly mistakes like that. Let's now come down. All right. So I'm going to go 27 plus 96, 127 minus 4, 123, 123 over 4. Negative 63 minus 60. Oh, would you look at this? 123 over 4. Look at that. You know what that's going to equal, everyone? Do you? It's going to be equal to 0. Why is that such good news? Therefore, x equals, now it was 3 over 2, wasn't it? Oh, I have to go check. What was it? 3 over 2 is my root. I can figure out my factor now by going 2 times x is 2x minus 3. That right there is the factor of p of x. So that took a long time just to get one factor. So let's now zoom out, zoom. 2 of x minus 3. So now what I'm going to have to do is come up to my second step now, which is divide. So remember what our factor is, 2x minus 3. I'm going to come up here, and now I'm going to do some division. So I come over here, and I'm going to go 2x minus 3. I'm going to divide that by my polynomial I started with. So this one right here. So 2x cubed minus 7x squared plus 16x minus 15. I come over here, Let's do some division. Now, when we were in class, we talked about how when you're dealing with a non-monic divisor, a way you can do this is equating coefficients, and you can absolutely do that if you want. It will work. But because I know that this is a factor and that it's going to go in nicely, doing just your traditional long division is going to be fine as well. And you might also be thinking to yourself, oh, can we use synthetic long division here because it's so much quicker? And you can't. You cannot use synthetic long division here because you can only use synthetic division. You can only use synthetic division when you do not have when your coefficient is 1. Because it's 2, you can't use it. So you can't do synthetic division here. Even though synthetic division is so lovely, you can't use it here because you have a 2 as your coefficient in your divisor. So that means we're stuck with boring polynomial long division. So let's now give this a go. Okay, so let me change color. I'm going to go 2 of x divided by 2x cubed. So it's going to be x squared. Then I'm going to go x squared times 2x, 2x cubed. Then I'm going to go x squared minus 3x minus 3x squared. Then I'm going to put brackets around this. I'm going to subtract. I'm going to put a line here. Negative 7x minus 3x. That's going to be positive 3x. So that's going to be negative 4x squared. Then I'm going to drop this down to get plus 16. That's an ugly 6. 16x. Then I'm going to go, how many times does 2x go into negative 4x squared? It goes in negative 2x times. I know that because negative 2x times 2x is negative 4x. I then come down and I'm going to go negative 2x times 2x is negative 4x. Then negative 2x times negative 3x is plus 6x. Then I'm going to subtract, put a line there. So that means I'm going to get, they're going to go away. It's going to be 16x minus 6, which is 10. Whoa. 10x. I'm way too zoomed in. Let me zoom out a bit, just so you can see it all at once. It might be a bit disorienting not being able to see it all at once. So this is going to be negative 15 here. I drop that down. Then 2x divided by 10x is going to be plus 5. Because 5 times 2x is 10x, then I'm going to go, this is going to be 10x. It's going to be 5 times negative 3 is negative 15. Let me come down. I now am going to subtract that. They're going to go away. This is going to become positive, and that means I'm going to be left with a remainder of 0, which we knew was going to happen all along. So that means I'm finished with this step. Now I can write it in my third step. So I'm going to say it's going to be 2x minus 3, 2x minus 3, x squared minus 2x plus 5. Now, the third step is called factorize, because if you can factorize this one at the end, you should. But what are two numbers that you can multiply to get 5 and plus together to get negative 2? No number exists. So factorize, no. Or you could say NA, not applicable. Yeah, that's more applicable. That's more. So then you're stuck there. That's your answer. Hopefully that's been helpful to you. We're done. 2x minus 3, x squared minus 2x plus 5. Yep, that's the answer. Hopefully this video has been helpful to you. Let's just zoom out and just look at all the work we just did. It took quite some time, and you can imagine this would have taken even longer if our trial and error didn't work the first time. So let's just thank the heavens that it did. Hopefully this was helpful to you in answering this question.